Hello everyone, my name is Rashid Abdullah. Today I'm going to talk about gas hydrate in Black Sea. Uh, I will start my topic with outlines. What is the gas hydrate? Then I will talk about information about the area, which is the Black Sea, and the evidence of gas hydrate, and the elements needed for producible gas hydrate reservoirs in the Black Sea, and estimation of gas hydrate in Black Sea, and then the methods of production, and finally conclusions. Okay, now introduction about gas hydrate. What is the gas hydrate? Actually, gas hydrate, it is ice like crystalline structures formed by two things, which are uh, water and gas molecules at the high pressure and low temperature values. They are defined as non-stoichiometric compounds. Actually, there are three types of gas hydrate structures. Uh, the first one is the first structure is S1, which is the most common in the world. And then also the structure 2 also most common as structure 1, and the structure 3, which is S3, are not common as one type 1 and type 3. And as you can see here, also the uh, structure of the three types of the gas hydrate, as you can see and notice that there are they have different shapes, and they are explaining their uh, their structure, chemical structure. Okay. Now, the compounds of frozen water that contain gas molecules divided to two, the ice molecules, which is called clathrates, and the second one white and broady snow. Also, structure 1, as I said, that structure 1 and structure 2 are the most common ones all over the world. Uh, and gas hydrate requires high pressure and low temperature. This is the most important uh, values to be formed. Uh, the gas hydrate are mostly found in the marine environment. For this reason, it requires low temperature, as it is in the marine or in the ocean. It's also known that even the most conservative estimates place in the amount of the gas contained within hydrate deposits at 2 to 10 times larger than the global estimates of the conventional natural gas of 4.4 trillion standard meter cube. Also, the information of gas hydrate um, at pressure and temperature conditions outside the stability zone, methane is no longer bound in methane ice. So it must be in order to be in order if to be gas hydrate. So it must be in the stability zone, not outside the stability zone. So um, and exists only as a free gas or gas dissolved in pure waters. Uh, One of the most important information for gas rate is 1 feet cube of gas hydrate release 164 feet cube of natural gas. That's huge amount. And estimates of the naturally occurring gas hydrate resource vary from 10,000 feet cube to 100,000 feet of natural gas. Then we will go now to next step, which is explaining the area that we are focus on. Uh, Here is the Black Sea, the area that we are focused on. Black Sea is as well as marine environments in the world. The Black Sea has also high gas hydrate potential. In order to be understand the Black Sea gas hydrates, it is necessary to analyze the temperature gradient. I mean, some of parameters like temperature gradient, pressure gradient, gas source, and its type, and sediments type, salinity, and geological and geophysical data of the Black Sea. These all parameters can be collected from the course or from the modeling and many things that we can obtain from. The Black Sea is a deep valley which was filled with consolidated and consolidated sediments above basal and mantle layer. The sedimentation rate in the Black Sea is high because the Black Sea is almost a closed area. Uh, it is as it was shown in the map. It is surrounded by 6 countries: Russia and Turkey, Georgia and Bulgaria, Romania and Ukraine. Uh, Here now we can move to the next slide. The Black Sea, it's warm bottom water temperature of 9 Celsius and salinities of 20.3 control the gas hydrate stability zone, which is occurs in water depth greater than 7,720 meters. It is also known that the main component of the gas from the Black Sea hydrates is methane, with approximately a range between 93.3 to 99.7%. This is good resource. Also, it was stated that uh, uh, as going deeper through the methane hydrate stability zone in the Black Sea, hydrate saturation might increase up to 45 to 60%. As you see here, this is the map of the Black Sea. It shows that the depth of Black Sea. Here, as you see, the most deeper with start with blue or the darkness, and then come up to the red color, the most high. As you see here, we have very deep, area in the map of the Black Sea. Almost the Black Sea is deep, very deep. So now I will talk about evidence of gas hydrate extensions in the Black Sea. There are four evidence or claims that show us that there is or there are probability of exist of gas hydrate, which are gas sweepages, mud volcanoes, and seabed samples and BSR. I will talk now about one by one. As I said, that it's very important to have low temperature and high pressure to form gas hydrate. In this graphs, it's explain us uh, how it looks like if the gas hydrate. I mean the area where gas hydrate can be formed. Uh, I can move here from this slide. So I will talk now about, as I said, that, the evidence of gas hydrate in the Black Sea. First of one is gas seepages. First evidence is gas seepages. Sorry, the reason of this gas seep is that at certain temperature condition, gas pressure is below hydrate equilibrium figure. It as it's here. This is the map of area that located. I mean, it's located in the near to the Bulgarian coast. It shows us that there are some gas seepages. This is a clue, very clue or evidence that there must be gas hydrate. The main reason that of existence of free gas in gas hydrate stability zone are high salinity effect of resident waters and digesting from uh, exceeding fluids, bound water effect in the evidence of free waters, and micropore effect of porous medium. In general, three types of seeps are absorbed in the Black Sea. There is a seep in the shallow of the sea, in the Black Sea, near to the coasts, and there is also in the deep sea, and also there is, I mean, in the gas hydrate stability zone. So it is in the down after sea floor, after the floor sea. According to the Veselov and Demirtov, they are from Russia. The area of the Black Sea suitable for gas hydrate formation is evaluated at um, 288 kilometer point 100 kilometer square, representing about almost 69 or 68.5% of the total Black Sea, or almost 91% of the deep water basin. So this is good information that uh, we know that there is uh, gas hydrate in the Black Sea. As you see here, as I said, that there is clues that and seep near to the Bulgarian coast. This composition includes like 92 between 92 and 96.3 percentage of methane and 0.2% of carbon, and also there is a little bit of carbon dioxide and nitrogen. And the second one of evidence of gas hydrate in the Black Sea, the mud volcanoes. Gas hydrate samples were also recovered for the first time in the northwestern part of the Black Sea, near to the Ukraine area, without mud volcanoes and at the water depth of 900 meters, as shown in the figures. As you see here, this is mud volcanoes. It is it gave us a clue that there is an gas there is gas hydrate in that area. The gas hydrate were recovered in Botormir region in the eastern part of the Black Sea. This is near to Georgia coast, and with TV grip or gravity color. The recovered gas hydrate samples contain 99.96, almost 100 of gas of methane gas. This is very important clue and very important. It's high value to I mean, explain that area, we can get high of the gas hydrate. The third one of evidence is seabed samples. As we know that it was observed that I mean the gas hydrate, it must be at color coarse fan coarse fin or matrix. It was observed that gas hydrate as nodules in the sediments in Crimean deep water marine in the Black Sea. Sea bed samples were collected in Amasra, Bartın, and Zonguldak, and Kuzlo in the central Black Sea by gravity color. By applying the head spice gas chromatography to seabed samples, it was observed that gas composition and the gas chromatography result represented hydrocarbon gases such as methane. And finally is the BSRs. This is like a model or like a method that to know whether there is gas hydrate or not. Actually, these techniques controlled source electronics method were reported by a very effective to determine shallow gas hydrates by imagining subsurface resistivity. In the Black Sea, multiple bottom simulating reflection occurs in high resolution reflection seismic data in the Danube deep sea or fan associated with the acoustic feature indicating free gas. So if we know that there is free gas in some area, so it might give us a clue that there is gas hydrate. As I said, that these techniques, BSR, is observation of bottom simulation reflection as an indicator for the presence of gas hydrate are documents for several areas in the Black Sea, like in the southwestern margin. And several studies carried out of the Danube Sea fan complex in the northwestern Black Sea revealed large bottom simulation reflections path. So also studies and on multiple bottom simulation reflection were carried out offshore Amasra, Bartın, Zonguldak in the central Black Sea. These authors conclude that the multiple the one who make this research, his name Kochuk, he he concluded that the multiple bottom simulation reflection are related to the different gas composition due to the presence of the thermogenic gas. Also, its the detection of the bottom simulating reflection during systematic study can give a clue about potential of class 1, which is the first type of gas hydrate. Now, the elements, I will talk the elements that requires for a producible gas hydrate reservoirs in the Black Sea. After identifying a gas hydrate reservoir, one should check the following elements to consider the reservoir as energy sources. Prepare the temperature condition below 30 Celsius. So this is a very important condition to form gas hydrate. Enough water depth to provide necessary overburden pressure. So as we said that high pressure and low temperature. Uh, Anoxic environment, which is considered as potential source of hydrate forming gases. As we see that the Black Sea is one of the seas in the world that is anoxic environment. Coarse sands with high porosity. So this is very important condition. The coarse is very important in the sediments in order to have uh, gas hydrate and high permeability as a reservoir rock. Also source gas and water in the pores. Temperature and deep sea depth, salinity, amount of source gas in the Black Sea is appropriate. And no information about the sediment type. All rocks eroded with rivers transported to the Black Sea are called as terignos mud. Therefore, for the better gas hydrate reservoir, coarse sand layers and coarse layers of turbidites are potential for sediments. Here, the turbidites, a sequence of layers that consist of chrono-classified set of sandstone start sediment generally in the finite powder upward that were deposited by turbidity currents. Turbidite sequence are good reservoir candidate for hydrocarbons. Uh, Also, coarse layers are favorable since gas cannot diffuse into it. So, as I said, that coarse layers is very important. No gas hydrate in fine layers. If we have fine layers, so it is possible that we can't find a gas hydrate. And if required conditions are met, pressure and temperature gas might be formed. Now, I will talk about estimation of gas hydrate in the Black Sea. We have the our equation uh, original gas in place, we have the porosity and thickness and area, and also the gravity fill ratio and explanation factor. We have this data from I get this data from the articles for Murray and Schaller research that belong to the gas hydrate in the Black Sea. uh, I calculate that the original gas in place, it was close to 71.8 trillion cubic cubic meter cubic, and in the others study that belong to another person who is from Russia. uh, he gave, he gave another data for Black Sea, and I calculate that his according to his data, that original gas in place, it equals to 97.964 trillion cubic feet. So there is a big difference. As you see here, in the chart, this information came from Mary and Schaller research. I get the data from there, and uh, we have to compare uh, the studies uh, according to their data and their techniques that they use. So, in order to get uh, reliable value, so we have to compare both of them. Here, as I said, that there are many studies there are many studies belong to gas hydrating, in the Black Sea. So there is a study that done at 900, 1989 by Kurosakov. He's from, I think, Russia. He calculated that the intentional gas in the place in the Black Sea hydrates, uh, it was between 40 to 50. And another studies that done by Koloda and Sandelar at 2003, they said that it was 850. That's very huge number. And also at the same year, one his name Shi, he 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 estimate that it was the essential gas, it is 42. And the study by Mary Ann Chala at 2016, it was at they said that it is 71.8 as I calculated before. Here I do Monte Carlo simulation. I have done this by myself according to the data that I get from Mary and Schaller research. I found that here for B90, which is proved by Monte Carlos, I get the I get the values actually by beat 90, it is 9.08. And also I got here P20, which is proved plus probability. It is 2.03 multiplied by so multiplied by 10 of 15. And also then and finally B9, which is 5.8 is a 5.49 of multiplied by 10 of 15. So as you see here, we got reliable or a reasonable chart at its indicate here with original gas in place. And then I will talk about production method. Actually, there are many methods. Depressurization, inhibitor injection, thermal simulation, and carbon dioxide injection methods. All these methods are suitable for gas hydrate in order to produce it. However, I mean, uh, all of them they have advantages and some disadvantages. The recovered gas hydrate sample contains 99.9 96% of gas of methane gas, which is an indication of S1 type. So as we mentioned before that most of the Black Sea has the type 1 of gas hydrate, class 1. So this forms this let I mean it led us to use one of these methods. I will talk about it later. Um Gas hydrate, class 1 hydrate appear to be the most promising target for the gas production. It is because its pressure is close to the hydrate equilibrium condition and it is easy to produce. Uh, the gas hydrate, there are some modeling for producing gas. Hydrate RES same modeling. This modeling, it's the production behavior of the hydratical class 1 hydrate, methane hydrate reservoir selected in the southern center part of the Black Sea was investigated by using this modeling and simulation by hydrate RESSIM were run for the depressurization production method of different production pressure with or without wellbore heating. So for this reason, we will use the first method, which is the pressurization. In conclusion, now there are many studies show that that use different methods of evaluation. As I said, that there are many studies that I compare. One of them was 71.8, and others was 97.9 oil original gas in place. There are there is a high gas source, potential in the Black Sea because of the optimum temperature and hydrostatic pressure of the Black Sea for forming gas hydrate. All course data that taken into Black Sea until now were logged from the well log 40 sorry 42B drilling program. High clay contact of sediments was detected. This causes low permeability, and all of us know that the importance of permeability is affect our production. Therefore, gas hydrate formation into a Black Sea cannot be produced due to their low permeability. This is one of the disadvantages that we get from the investigation in the Black Sea by leg 42B drilling. Also, the Black Sea is considered a potential reservoir. However, it has a very fine to fine silt. This is one of the disadvantages also. As we said that we need cross fin or cross sediments sands, salts, and as I said that by the Black Sea is considered a potential reservoir. However, it has a very faint to thin salt and sandy salt layers. Although thicker sand was also absorbed in the course of the lake um, 42B drilling program, there are must be a thicker layer to be good potential reservoir for gas production in the Black Sea. And this is my reference that I, t- I prepare my presentation from them. And thank you so much.